Bismillahirrahmanirrahim. Another topical question paper. It is part 4 and it's a solution of 10 sample questions. And the topic is DC circuits. Course is course is Cambridge O level physics. Course code is 5054. Let's start our session. Question number 1. The diagram shows a circuit. What is the reading on the ammeter when the switch is open and the reading when it is closed? When the switch is open, both six the current will flow through both 6 ohm resistors, and the current will see the resistance of 12 ohm because these two 6 ohm resistors are connected in series, and the ammeter will measure 12 volt over 12 ohm, that is 1 ampere. Okay, in second case, when the switch is opened, then when the switch is closed, then the current will only flow through one of the 6 ohm resistor, that is the resistor which is close to the ammeter, and the other 6 ohm resistor will be bypassed. And in this case, as the resistance has become half, the current will become twice. I is equal to V over R, 12 volt over 6, and that will be 2 ohms. So you can see case 1, switch is open, R is equal to 12 ohm and V is equal to 12 volt, I is equal to 1 ampere, and that's ammeter reading. Case 2, switch is closed, R is equal to 6, V is equal to 12, and I is equal to 2 ampere, ammeter reading. So option B. Ammeter reading when the switch is open, it is 1 ampere, and when switch is closed is 2 ampere. Question number 2. A student tests the circuit of a press button telephone with a lamp and a battery. Which single switch can be pressed to make the lamp light? If you carefully examine the 4 switches given in the options, that is 0 number switch or 1 number, 5 and 6 number switch, then you come to know that only 5 and 6 are connected to the lamp. Switch number 0 and 1 are not connected with any of the terminal of the lamp. And if you further investigate between switch number 5 and 6, then you come to know that only 5 number switch is connected with the positive terminal of the battery, whereas the lamp is connected with the negative terminal of the battery, and the other terminal of the lamp is connected to the switch number 5. So switch number 5 is the correct option. So lamp is connected only to switch number 5 and switch number 6 from the given options, and switch 0 and switch 1 is not connected to the lamp. As you can see, switch 0 and switch 1 are not connected to the lamp. Further, only switch number 5 is connected to the positive terminal of the battery, and thus can complete the electrical path for the lamp from positive to negative terminal of the battery. You can see switch 5 is connected to the positive terminal of the battery, and lamp is connected to the switch 5. So if switch 5 is closed, then the conventional current will flow through the switch 5 and the lamp will glow. And if the switch 5 is open, then no current will flow through the lamp. So correct option is option 5, switch number 5. Question number 3. A 6-volt supply is connected in series with an ammeter and a 4 ohm resistor. What is the reading on the ammeter? I is equal to V over R from the Ohm's law. So I is equal to 6 by 4, and that is equal to 1.5 ampere. Question number 4. Two resistors 6 ohm and 12 ohm are arranged in parallel. A potential difference is connected across the terminals X and Y. The current in the 6 ohm resistor is 4 ampere. What is the current in the ammeter? 6 ampere is flowing through the 6 ohm resistor, so the voltage drop across 6 ohm is 24 volt. V is equal to IR. And that 24 volt is also available or dropped across 12 ohm resistor, because 6 ohm and 12 ohm are connected in parallel. So 24 volt is available across 12 ohm, and that's why I through 12 ohm is equal to 24 over 12, that is 2 ampere. So 4 ampere is flowing through 6 ohm and 2 ampere is flowing through 12 ohm. And these are branch currents. The total current will be sum of these two branch currents, and the total current will be measured by the ammeter. So ammeter will measure 4 plus 2, that is 6 ampere. Question number 5. The diagram shows the components of a lighter of a lighter for a gas cooker. Which circuit diagram is correct for this lighter? There are two cells connected in series configuration, and in option A you can see the two cells are connected in series configuration. Okay, so one terminal of the resistor is connected to the positive terminal of the cell, and the other terminal of the resistor can make or break the circuit path through a switch, and the switch is connected to the negative terminal of the battery. So option A. Question number 6. An electric heater is rated at 3 kilowatt. Electrical energy cost 3 cents per kilowatt hour. What is the cost of using the heater for 5 hours? So energy is 3 kilowatt multiplied with 5 hours, and it is 15 kilowatt hours. The cost of electrical energy is 20 cents per kilowatt hour, and this cost will be multiplied with the total usage. Total usage is 15 kilowatt hour. So the cost of electric energy is 300 cents. Option D. Question number 7. At which point in the circuit is the current the smallest? The total current will flow through point A and point C. The current is equal at point A and at point C, and that current will divide itself in parallel configuration. Some of the current will pass through point D and some of the current will pass through point B. Now you can see the point D has the most resistance, that is 3 ohm. So the smallest current will pass through D, and comparatively larger current will pass through B. In fact, 25% of the total current will pass through D, and 75% or 3/4 of the total current will pass through B. So the smallest current will pass through D. It is the correct option. So total current passes through points A and C. It then divides in parallel branches and the smallest current will flow through D. Total current is coming from the battery and the current flowing in parallel branch D as a fraction of total current IT is given as. So you can see ID is equal to 1 over 4. 1 over 4 is the current divider ratio, and multiply this ratio with the total current. So ID is IT by 4. Question number 8. A student sets up the circuit shown. The currents measured with the ammeter are shown. Which equation is correct? I1 is the total current, whereas I2, I3, I4 are the branch currents flowing in the parallel combination of lamps. And total current is equal to all the branch currents. So I1 is equal to I2 plus I3 plus I4. So it's option A. Question number 8. The following circuit is set up. What is the reading on the ammeter? You can see 6 ohm and 6 ohm are in parallel, so the effective resistance is 3 ohm, and that 3 ohm will be in series with another 3 ohm. So there are two 3 ohm resistors in series configuration. So 6 volt will divide itself equally according to the voltage divider rule among these two equal resistances. So that means 3 volt is available across 6 ohm because voltage is same across the parallel elements. So the ammeter will measure I is equal to V over R, 3 over 6, and the correct option is 0.5 ampere. Solution is also given. So you can see 6 parallel 6. 6 parallel 6 is actually 3 ohm, and IT total current is 6 over 3 plus 6 parallel 6, that is 6 over 6, and that is equal to 1 ampere. The voltage drop in 3 ohm resistor is 3 into 1, that is 3 volt. You can also find it using the voltage divider rule. The voltage will divide itself equally in these two equal resistances. So 3 volt is available across the parallel branch, and current through the ammeter is 3 volt over 6 ohm, that is 0.5 amperes. You can see, so 0.5 ampere is flowing through the 6 ohm branch measured by the ammeter. Question number 10. Diagram 1 shows a resistor connected to a battery, an ammeter and a voltmeter. The ammeter reading is 0.5 ampere and the voltmeter reading is 3 volt. The second identical resistor is now connected in parallel with the first resistor as shown in diagram 2. What are the ammeter and voltmeter readings in the circuit shown in diagram 2? The reading in the voltmeter will remain unchanged and continue to show 3 volt because in parallel connection voltage remains the same, whereas the current will become double because in parallel combination of two identical elements the resistance becomes one half, and as the current is inversely proportional to the resistance, so the current will become twice. Okay. The potential difference remains the same in parallel configuration, so the voltmeter reading will not change and will show 3 volt. If two identical resistors are connected in parallel, then their effective resistance will become one half, and as a result the total current being provided by the battery will become twice, and the ammeter will measure 1 ampere. So it is option A. Current becomes double, whereas the voltage drop across the parallel combination of elements remains the same. Option A.